Hello students, I am Rakesh Umdi, HOD of Mathematics Department in Chain Polytechnic, Belagavi. Today I'll be discussing a very important topic in Engineering Mathematics 1, that is matrix and determinants. The subtopic is matrices. In this matrices topic, I'm going to cover definition of the matrix, types, algebraic operations on the matrices, adjoint of the matrix, inverse of the matrix, and characteristic equations and roots of the matrix. First, we'll see the definition of a matrix. A matrix is a rectangular array of numbers arranged into rows and columns enclosed by parentheses or square brackets. Example, here we have two matrices. Here numbers are arranged in rows and columns. Same here, numbers are arranged into rows and columns and enclosed in a bracket. Hence these two are called as matrix. Order of a matrix. If there are m rows and n columns in a matrix, then the order of a matrix is m by n. Example, if A is a matrix, here numbers are arranged in 2 rows and 3 columns. Hence the order of this matrix is 2 by 3. Now let's discuss the types of matrices. There are so many types of a matrix, but I'll be discussing a very important types. First one, row matrix. A matrix having only one row and any number of columns is called as a row matrix. For example, A is a matrix which is having a single row, but we can include many columns in it. The second type is column matrix. A matrix having only one column and any number of rows is called as a column matrix. This is exactly opposite of this. For example, B is a matrix which is having only one column, but we can include many rows in it. Next, the third type is square matrix. A matrix which has equal number of rows and columns is called as a square matrix. For example, here we have two matrices. In these both the matrices, the number of rows and columns are equal. This matrix is of order 3 by 3 and this matrix is of order 2 by 2. Both the matrices, number of rows and number of columns are equal. The next type is null matrix or zero matrix or void matrix. If all the elements of matrix are 0, then the matrix is called as a null or zero or void matrix. For example, this is a matrix of order 2 by 2. Here all the elements of zeros. And second example, this is a matrix of order 2 by 3 and again here all the elements are zeros. Therefore they are called as null matrix. Diagonal matrix. A square matrix with all the elements are equal to 0 except those in the leading diagonal or principal diagonal is called as a diagonal matrix. Here we have one example. Here all the elements are zeros, but except these principal diagonal elements. These are non-zeros. Such a matrix is called as a diagonal matrix. The last type is unit matrix. Unit matrix is a square matrix in which the principal diagonal elements are all ones and all the other elements are zeros, and it is denoted by I. Here we have an example of an identity matrix or a unit matrix. In this matrix, all the elements are zeros, but the principal diagonal elements are all ones. Similarly, we have a matrix of order 2 by 2. This is also a unit matrix. Next, we will be discussing algebra of matrices. Here in this topic, I'll be covering addition of matrices, subtraction of matrices, multiplication of two matrices, transpose of two matrices. Let's start with the addition of matrices. If A and B are any two matrices of the same order, this is very important, they should have same order, then only we can add the two matrices. Their sum A plus B is of the same order and is obtained by adding the corresponding elements of A and B. And for the subtraction of matrices also a rule is same. If I want to subtract any two matrices, then they should have same order, then only I can subtract them. Multiplication of two matrices. Two matrices can be multiplied if and only if number of columns of A matrix is equals to number of rows of the second matrix, that is B matrix. For example, A and B are two matrices. The order of A is 2 by 3 and order of B is 3 by 2. Here number of columns of first matrix are equal to number of rows of the second matrix. Hence we can multiply these two matrices. Next one is transpose of a matrix. If a row and column of a matrix are interchanged, then the resultant matrix is called as a transpose of a matrix, and it is denoted by A raised to T or A dash. For example, if A is any one matrix of order 3 by 3, then its transpose is, just I have changed here rows into columns, then this will be the transpose of a matrix. Now we will study addition, subtraction, multiplication and transpose of matrices by some examples. I have taken here some examples which are important. If A and B are two given matrix, find A plus B. I have to find out A plus B. Therefore, matrix A plus matrix B I have written. Now I have to add the corresponding elements of two matrices. That is, 5 should be added with 2, minus 2 should be added with 1, minus 7 should be added with minus 1, 1 should be added with 4. After adding the two matrices, the elements, then I'll get A plus B, that is 5 plus 2 is 7, minus 2 plus 1 is minus 1, minus 7 plus minus 1 is minus 8, 1 plus 4 is 5. Second example is, if A and B are two given matrices, then find 3A minus 2B. Here 3A minus 2B, in 3A I have to subtract 2B, that is 3 into matrix A minus 2 into matrix B. This 3 I have to multiply with each and every element of A, and 2 should be multiplied with each and every element of B before I subtract them. So 3 ones are 3, 3 minus 1s are minus 1, 3 2s are 6, 3 3s are 9. Similarly, 2 I have multiplied with each and every element and I got this matrix. Now let's subtract. Both the matrices are having same order, so they can be subtracted. 3 minus 6, minus 3 minus 4, 6 minus 2, 9 minus 8. That is 3a minus 2b matrix will be 3 minus 6 is minus 3, minus 3 minus 4 is minus 7, 6 minus 2 is 8, 9 minus 8 is 1. This is how we have to add and subtract. Now we'll see how to multiply two matrices. I have taken here two examples. Find A into B if A and B are some given matrices. Now I want A into B, therefore a matrix A into matrix B. Alright. Here little bit it is different. We have to multiply row with columns and add the elements. How to multiply I'll tell you now. 2 3s are 6, 3 7s are 21. These two numbers should be added. 2 6s are 12, 3 8s are 24, 4 3s are 12, 5 7s are 35, and again these two numbers should be added. 4 6 are 24 plus 5 8s are 40. Now let's add the numbers. 6 plus 21 is 27, 12 plus 24 is 36, 12 plus 35 is 47, and 24 plus 40 is 64. This is A into B matrix. One more example for the multiplication, because the multiplication of the matrices is complicated. We have to understand it very carefully. If A and B are two given matrices, then find A into B. First we'll check, can we multiply these two matrices or not. Here number of columns of first matrix are equals to number of rows of the second matrix, hence we can multiply these two matrices. Now I'll multiply. 2 5s are 10, minus 1 3s are minus 3, 3 2s are 6. Similarly, row into second column. 2 minus 2s are minus 4, minus 1 1s are minus 1, 3 4s are 12. Now just we have to add the numbers. We'll get 10 minus 3 is 7, 7 plus 3 6 is 13, minus 4 minus 1 is 5, minus 5, minus 5 plus 7 is 12 is 7. Now we will see how transpose is done with some basic operation. Here they are asked to find out transpose of A plus transpose of B if two matrices are given, A and B. That is, A transpose plus B transpose will be is equals to transpose of matrix A, rows are changed into columns, plus transpose of matrix B, rows are changed into columns. Now I'll add the corresponding elements. 1 plus 4, 3 plus 2, 5 plus 5, and 6 plus 8. The resultant matrix is 5 5 10 14. After adding the elements I'll get this matrix. After this, after the basic operations or the algebraic operations on the matrices, now we'll move to the next part of the matrices, that is adjoint of a matrix. The transpose of a of the cofactor matrix is called as adjoint matrix. It is denoted by adjoint of A. For example, here we have one matrix A. The cofactor matrix is obtained by taking the cofactor of each and every element. Cofactor of 3 is 4, I have written here. Cofactor of 2 is minus of minus 3, that is plus 3. Cofactor of minus 3 is minus 2, and cofactor of 4 is plus 3. If I want to find out adjoint of matrix A, then I have to transpose this cofactor matrix, that is rows are changed into columns. 4, 3 I have written in column form, minus 2, 3. This is the adjoint of the matrix A. Now we have discussed the adjoint of a matrix 2 cross 2. Now we will move on to the next 3 cross 3. How to find out the adjoint of 3 cross 3 matrix. Here they are given one matrix. They are asked to find out the adjoint of this matrix. Now I will take the given matrix. Here we have to find out cofactor matrix of A. That is, find out the cofactor matrix of cofactor of each and every element. The cofactor of 3 is plus minus 3, 1, 4, 2. Cofactor of minus 1 is 2, 0, 1, 2. Minus. Cofactor of 2 is plus 2 minus 3, 0, 4. Cofactor of 2 is minus 1, 2, 4, 2. Cofactor of minus 3 is plus 3, 2, 0, 2. Cofactor of 1 is minus 3 minus 1, 0, 4. Cofactor of 0 is plus minus 1, 2, minus 3, 1. Cofactor of 4 is minus 3, 2, 2, 1. And the last one is cofactor of 2 is 3 minus 1, 2 minus 3. I have taken the cofactor of each and element. Let me solve this. Cofactor of A, you know how to solve the 2 cross 2 determinant. I'll get, after solving this, minus 10, minus 4, 8, 10, 6, minus 12, 5, 1, minus 11. But I want the adjoint of a matrix. So I have to transpose this cofactor matrix. That is, rows are changed into columns. These 3 rows I have changed into columns, or these 3 columns are changed into rows. Next, we'll move on to the inverse of a matrix. Now we'll understand what is inverse of a matrix. Let A be a non-singular square matrix if there exists a square matrix B such that A into B is equals to B into A is equals to I, where I is a unit matrix of the same order as that of A, then B is called the inverse of the matrix A, and it is denoted by A inverse. This can be determined using the formula A inverse is equals to adjoint of A divided by determinant of A. Let's understand this concept using one example. Find the inverse of the matrix A, 5, 2, 3, 6. Here they are given 2 by 2 matrix. Now A matrix they are given. First I have to find out adjoint of A, then I have to find out determinant of A. You know how to find out the adjoint of A. First we have to find out cofactor matrix of A. Cofactor of 5 is 6. Cofactor of 2 is minus 3. Cofactor of 3 is minus 2. And the cofactor of 6 is 5. I have written the cofactors. Adjoint of A will be transpose of cofactor matrix. Just interchange rows into columns. Here we have adjoint of a matrix. Determinant of matrix A. We have to find out the determinant value of A. You know how to find out. 5 6 are 30 minus 3 2s are 6. 30 minus 6 is 24. A inverse is equals to adjoint of A divided by determinant of A. That is adjoint of a matrix divided by determinant of a matrix. That is 24. Similarly, we'll solve the we'll find the inverse of a matrix of order 3 by 3. Here they ask to find. Now we'll see another example for inverse of a matrix of order 3 cross 3. Here we have one more example. Find the inverse of matrix. The given matrix is of order 3 cross 3. Now we have to find out first cofactor of matrix A. Then I have to find out cofactor of each and every element. After finding the cofactor of A, we have to transpose the cofactor matrix. The transpose of cofactor matrix gives us adjoint of A. After finding the adjoint of a matrix, I have to find out the determinant of the given matrix. We all know how to find out the determinant of a matrix. That is, we have to expand the given determinant along any row or any column. Now I'll expand this using the first row. 1 into 3 minus 0 minus 2 into minus 1 minus 0 plus 2 into 2 minus 0. That is equals to 3 minus 2 minus plus 2, 2 to the 4 plus 4. The answer is 9. A inverse is equals to adjoint of A divided by determinant of A. We all know this formula. So I am going to substitute the value of adjoint of A and determinant of A. The adjoint of A matrix is, we obtained it previously. This matrix I have to substitute there and divide it by the value of the determinant A, that is 9. Now the last part in this matrices is characteristic equation and Cayley-Hamilton theorem. First of all, we'll understand how to find out the characteristic equation, characteristic roots. The characteristic roots are called also called as eigenvalues, and verification of a Cayley-Hamilton theorem. Now we have one example here. Find the characteristic equation and its roots of a matrix A. 1, 2, 2, 1. The given matrix is of order 2 by 2. First, we know that Cayley-Hamilton equation, that is determinant of A minus lambda I is equals to 0. Determinant of A matrix minus lambda into the identity matrix will be is equals to 0. I have multiplied lambda with each and every element as lambda being a scalar quantity. Then I'll subtract the corresponding elements of the two matrices. Then I'll get 1 minus lambda, 2, 2, 1 minus lambda. Determinant of this will be equals to 0 according to this formula. Now I'll expand this determinant. 1 minus lambda into 1 minus lambda, middle minus 2 2s are 4 is equals to 0. Multiply these two binomials. 1 into 1 is 1, minus into minus plus lambda into lambda, lambda square, and then minus lambda, 2 lambda. That I have expanded this using the formula A minus B whole bracket square minus 4 as it is equals to 0. Now lambda square as it is minus 2 lambda, 1 minus 4 is minus 3 is equal to 0. I have written in linear form. Now I'll find the factors of this. Now lambda square minus 3 lambda plus 1 lambda minus 3 is equal to 0. This equation can be written as like this. We can take lambda common from these two terms and 1 common from these two terms. I'll get lambda into lambda minus 3 plus 1 into lambda minus 3 is equal to 0. Out of these two, lambda minus 3 is common and hence lambda plus 1 will remain. Lambda minus 3 may be 0 or lambda plus 1 may be 0. That's why lambda is equals to minus 3 if you send this side, it will become plus 3, and lambda is equals to plus 1 if you shift this side, it will become minus 1. Now here, this is called as the characteristic equation, and these two are called as characteristic roots or eigenvalues. Now one more example is of verification. Verify Cayley-Hamilton theorem if given matrix A is equal to 1, 3, 2, minus 4. Now the given matrix A, I have taken it. Now we know CH equation, that is determinant of A minus lambda I is equals to 0. Determinant of matrix A minus lambda into the identity matrix will be equal to 0. Now lambda I will multiply with each and every element of the identity matrix. This matrix as it is, minus I have multiplied lambda with this matrix. Now we will subtract the corresponding elements of these two matrices. I will get 1 minus lambda, 3, 2, minus 4 minus lambda. We have to take the determinant of this matrices that is equal to 0. Now we'll expand this matrix of order 2 by 2. 1 minus lambda into minus 4 minus lambda. Minus 2 3s are 6 is equal to 0. 1 into minus 4 minus 4. 1 into minus lambda minus lambda. Minus lambda into minus 4 plus 4 lambda. Minus into minus plus lambda into lambda, lambda square. Minus 6 is equals to 0. That is lambda square. 4 lambda minus 1 lambda is 3 lambda plus 3 lambda. Minus 4 minus 6 is minus 10 is equal to 0. I have written in the linear form. This is called as characteristic equation. But we have to verify Cayley-Hamilton theorem for the given matrix. Therefore, what we have to do, in this CHR equation, characteristic equation, all the lambdas are replaced by matrix A. That is lambda square is A square. 3 into lambda is 3A minus 10 into. This is a simple scalar quantity. We can convert this into matrix form by multiplying identity matrix, that is equals to 0. A square is the matrix A into A. This will give us A square plus 3 into the matrix A minus 10 into the matrix identity matrix I. This we have to prove that equals to 0, means it is equals to a null matrix or the 0 matrix. Now multiply along the row into column. 1 1s are 1, 3 2s are 6, 1 plus 6 is 7, 1 3s are 3, 3 minus 4s are minus 12, 3 minus 12 is minus 9, 2 1s are 2, minus 4 2s are minus 8, 2 minus 8 is minus 6, 2 3s are 6, minus 4 minus 4s are plus 16, 6 plus 16 is 22. I multiplied these two matrices plus 3 I have to multiply with each and every element of this matrix. 3 1s are 3, 3 3s are 9, 3 2s are 6, 3 minus 4s are minus 12, minus 10 I have to multiply with each and every element of this. 10 1s are 10, 10 zeros are 0, 10 zeros are 0, 10 1s are 10. Now I'll add and subtract the corresponding elements of these two matrices. 7 plus 3 minus 10. I have written minus 9 plus 9 minus 0, minus 6 plus 6 minus 0, 22 plus into minus minus 12 minus 10, 7 plus 3 is 10, 10 minus 10 is 0, minus 9 plus 9 is 0, 0 plus 0 is 0, minus 6 plus 6 is 0, 0 minus 0 is 0, 22 minus 12 is 10, 10 minus 10 is 0. Hence, we have verified as we got the end answer as a null matrix.